Welcome to another NUCIDA video. Ever wonder how software testers ensure the software you use is bug-free and performs as expected? Well, the secret lies in the art of test design techniques. These are systematic approaches that testers employ to ensure software quality. They're the unsung heroes of the software development lifecycle, playing a critical role in ensuring that the end product is as polished as possible. From identifying potential issues to mitigating risks, they're crucial in every step of the process. So, what are these techniques that testers use to ensure software quality? First off, we have the black box technique, a method that doesn't require any knowledge of internal design or code. This technique, also known as functional or specification-based testing, focuses solely on the inputs and outputs of the system under test. The tester does not need to understand how the system works internally, hence the term black box. It's as if you're examining a mysterious black box, focusing on what goes in and what comes out, without knowing what happens inside. Now, you might be wondering where you would use the black box technique. This method is incredibly versatile. It can be applied in unit, integration, system, and acceptance level testing. It's particularly useful for validating functional requirements, testing software with complex code that's hard to understand, and when the tester does not have access to the source code. Let's talk about the advantages. Firstly, black box testing is unbiased as the designer and the tester are independent of each other. It's also efficient for large code segments and helps identify discrepancies in the system before they become problematic. Because it's based on user expectations, it's great for finding gaps between the system specification and the actual system output. But like all things, it's not without its drawbacks. Black box testing can be time-consuming to create test cases without clear specifications. It's also tricky to identify all possible input combinations, and since it doesn't look at the internal logic of the system, it may leave many program paths untested. However, despite these challenges, the black box technique remains a popular and effective tool in software testing. It's easy to use, flexible, and doesn't require technical know-how, making it accessible to a wide range of testers. While the black box technique is powerful, it's not the only tool in a tester's arsenal. Having understood the basics of the black box technique, let's delve deeper and explore some of its key methods. These include equivalence analysis, boundary value analysis, decision table test, and pairwise testing. 1. Starting with equivalence analysis, this method divides input data of software into different equivalence data classes. The idea here is simple. If a program works for one representative scenario in a class, it should work for all. This helps to reduce the number of test cases while ensuring broad coverage. 1. Next we have boundary value analysis. This technique involves testing at the extreme ends of input domains. Bugs often lurk at the edges, and this technique helps to flush them out. For example, if a program is supposed to accept numbers from 1 to 100, test it with 0, 1, 100, and 101. 1. The third method is decision table testing. This method uses a table to represent combinations of inputs. It's especially useful when dealing with complex business rules that can be hard to capture with other methods. 1. Finally, we have pairwise testing. This technique tests all possible discrete combinations of parameters. It's based on the observation that most defects are caused by interactions of just two variables, hence the name pairwise. These methods under the black box technique umbrella help testers ensure comprehensive coverage with efficient use of resources. By understanding and using these methods effectively, you can make your black box testing more precise and targeted. But remember, no one method is superior to others. The choice of method depends on the software under test, the stage of development, and the resources available. Now that we've taken a deeper dive into black box testing, let's shift gears and delve into the inner workings with the white box technique. Moving on to scene 4, we dive into the concept of the white box technique, an innovative strategy that probes deeply into the software's core. This technique, alternatively referred to as clear or glass box testing, offers a detailed insight into the intricate operations of the software. It is akin to a transparent exploration, where the reviewer has a crystal-clear comprehension of the software's internal mechanics. In the world of software testing, the tester, armed with thorough knowledge about what the software aims to achieve and the specific strategies it employs, can create test scenarios that cover every potential path and logical division of the software. They're not merely bystanders, but active participants, examining every line of code for hidden anomalies. White box testing is a meticulous process that transforms the tester into a detective, scrutinizing the code to unearth hidden errors and glitches that might not be obvious at the surface. What sets this technique apart is its proficiency in revealing concealed bugs, logical discrepancies, and inadequate error handling, issues that other methods may find challenging to spot. The most common test design techniques in that area are statement tests and decision tests. However, like all things, the white box testing does have its downsides. It demands the tester to possess a profound understanding of the programming language and the structure of the software. Acquiring this skill set isn't a task that can be accomplished overnight. It needs a painstaking dissection of each line of code, which naturally necessitates significant time and dedication. Despite these drawbacks, the merits of the white box technique significantly outweigh the cons. This method can discover issues that might elude other testing techniques, ensuring the code is robust, effective, and dependable. It's similar to conducting a thorough health checkup for your software, certifying that everything is operating flawlessly from inside out. Another aspect that adds to the allure of the white box technique is its flexibility. Irrespective of whether it's the preliminary stages of coding or the final steps of software development, this technique can offer vital insights to enhance your software's quality at any stage. Though the white box technique demands a greater effort and expertise, it is an invaluable asset in a tester's toolbox. It's a secret weapon that can unveil issues that might otherwise remain concealed. With the white box technique, testers have the prowess to expose the latent issues within the code, charting a distinct path towards enhanced software quality. But what if we amalgamate the strengths of realms? The white box technique empowers testers to expose issues that might be concealed in the code. But imagine the possibilities that arise when we blend the best of both worlds. Welcome to the gray box technique, a hybrid method that combines both black and white box techniques. This is where we plunge into the realm of compromise in scene number 5. Fusing the best of both worlds to achieve a balanced view of our software testing. Gray box testing, as its name intimates, is not entirely black or white. It's a middle ground that allows us to sneak a look inside the box whilst not being fully immersed in it. This technique merges the user-driven approach of black box testing with the intricate, code-focused approach of white box. It's akin to being a sleuth with a magnifying glass, searching for clues both on the surface and a touch. This technique is notably beneficial in integration testing, where different components of a software system unite. Here, the gray box method allows testers to comprehend the user interface and the interactions between various components, whilst also catching a glimpse of the underlying code. It's similar to being able to observe the gears of a clock, whilst also appreciating the time it displays. However, as with everything, the gray box technique has its pros and cons. On the plus side, offers a more thorough testing scope than either black or white box testing individually. It provides a profound understanding of the system under test, which can lead to more effective bug detection and resolution. On the downside, gray box testing necessitates a certain level of familiarity about the internal workings of the system, which may not always be accessible to testers. Moreover, it may be more time-consuming and intricate compared to other techniques. Nonetheless, the allure of the gray box technique lies in its equilibrium. It amalgamates the best of both black and white box techniques, providing a comprehensive and effective approach to software testing. The gray box technique offers a balanced approach, but there are even more methods that testers can apply. Thus, let's proceed with our exploration into the enthralling world of test design techniques. Coming up next, we dive into the domain of experience-based techniques. Stay tuned. Ever heard of experience-based techniques? These rely heavily on the tester's knowledge and expertise. Welcome to scene number 6, where we dive into the intriguing world of experience-based techniques. They're a unique approach to testing, where the tester's knowledge, intuition, and expertise play a pivotal role. These techniques are less about following a strict protocol, and more about leveraging the tester's skills, insights, and past experiences. Experience-based techniques come in various forms. The first is exploratory testing, where the tester actively controls the design of the test as those tests are performed and uses information gained while testing to design new and better tests. It's like exploring an unknown territory where each step could reveal something and unexpected. The second is error guessing, a technique where the tester uses their experience to anticipate where errors might occur and then designs tests specifically to uncover those errors. It's like a detective using their intuition and knowledge to solve a mysterious case. The third is checklist-based testing. Here, the tester uses a checklist as a guideline to ensure they cover all necessary aspects. It's like a cook following a recipe, ensuring each ingredient is in place for a successful dish. Now, what makes these techniques valuable? Well, they are incredibly flexible and adaptable. They allow testers to think outside the box, find unique solutions, and uncover hidden bugs. Moreover, they can be used in conjunction with other testing techniques, creating a robust and comprehensive testing strategy. But like everything else, they have their downsides. These techniques heavily rely on the tester's skills and experience. Therefore, they may not be as effective if the tester is inexperienced or lacks knowledge about the system being tested. Furthermore, these techniques can be somewhat unpredictable. Since they are not strictly defined, the results can vary significantly between different testers or even different testing sessions. Experience-based techniques can be invaluable, but remember, they are just one part of a comprehensive testing strategy. Let's keep exploring, shall we? We've traversed the enthralling realm of test design techniques, but what does it all signify for you? In the 7th chapter of our journey, we've delved deep into the black box technique, which concentrates on the functionality of the software, disregarding internal structures. This technique resembles a detective solving a mystery, using hints from the software's behavior to expose potential issues. Then we transition to the white box technique, where we unravel the software to scrutinize its internal structures. Just like a mechanic inspecting an engine, this technique empowers us to pinpoint problems at their roots and rectify them before they escalate into larger issues. We also navigated through the gray box technique, a fusion approach that amalgamates the best of the black and white box techniques. This method is like a detective collaborating with a mechanic to ensure that the software operates seamlessly, both superficially and internally. Last but certainly not the least, we unveiled experience-based techniques, which depend on the tester's acumen and intuition. This is akin to a seasoned chef, who can concoct a scrumptious meal grounded on years of experience and a profound understanding of the ingredients. Each of these techniques has a pivotal role in assuring software quality. They're like the implements in a handyman's toolbox, each with its distinctive purpose and all of them collaborating to create something splendid. Bear in mind, the objective of these techniques is to guarantee that the software you utilize is dependable, effective, and free from bugs. Until our next encounter, continue exploring the world of software testing. In further videos, we will explain the most common test design techniques in detail step by step. Thus, stay tuned and subscribe to our channel.